Good morning, my dear students. Today, we want to continue from where we stop on statistics. My name is S.Adebayo. We shall be considering range, variance, standard deviations. We will also look at some basic calculations on range, variance, and standard deviation. And lastly, we look at the practical application of the capital market reports in health, health studies, and population studies. In our last classes, I told us something around last two classes. I said we have statistics being classified into two broad aspects. The first aspect is the measure of location, or we call it measure of central tendency. And I said the second one is measure of dispersion. So all mean, mode, and median that we have done so far are measures of location or measure of central tendencies. But today we shall be considering the measure of dispersion. Measure of dispersion. And the measure of dispersion is also called measure of variation. The measure of central tendency is also called measure of location. So this is a variation. So the measure of dispersion, also called measure of variation, is concerned with degree of the spread of numerical value of a distribution. So when we consider how a kind of value given to us is being spread, or the degree at which that data is spreading, what we are discussing will be measure of dispersion. Now, the first thing I will want to explain here is range. Range. The difference between the maximum and the minimum values in the data is called range. So whenever we are given any data and we are asked to get the range or find the range, the differences between, or the difference rather, between the maximum and the minimum value. When you pick the minimum value of the data and the minimum value of the data, you now do the subtraction. The actual value that we are going to get is the range of that value. Look at the data that we have in example 1 here. Find the range of the data 6, 6, 7, 9, 11, 13, 16, 21, and 32. The maximum item or the maximum value here is 32. Why the minimum out of all the data given to us is 6? So range will definitely be 36 minus 6, which is 26. That's the range. Now, we have to find the range of this distribution too. The distribution is 65, 62, 62, 61, 61, 60, 60, 59, 58, 52. Now, that can be done as a classwork anyway, but if you look at this data, we will see that the maximum data or the maximum value here is 65. That is 65 here, and the minimum value here is 50. Do we have anything? Yeah, 52. We don't have anything less than 52. No, 52. So our range will actually be 65 minus 52. That's our range. So what would that give to us? That would be, we have 8, 5. Let me just write it here. 65, 52. What do we have? We have 3 and 1. So our range will be 13. 13. So deviation from the mean is another thing I want to discuss. Deviation from the mean. If the meaning of the distribution is subtracted from any value of in the distribution, the result is called deviation of the mean from the mean. Whenever we have any distribution given to us, anytime we subtract the mean, or anytime we subtract any value from the mean, or when the mean is subtracted from the value, whatever score we have is the deviation from the mean. Looking at the set of data given to us here, we have 65, we have 62 appearing 60 times, 62 another 59 times, 61, 50 we have. By the time we calculate the mean here, the mean will be summation of all the data over the number of the items. Excuse me, this table is not explicitly drawn enough. Let me check. Okay. 65. Okay, I think the table is right. These are 65, 62, 62, 61, 61, 60, 60, 59, 58, 52. There are 10 data that we have. So the mean will actually be summation of all these data divided by the number of data, which is 10. So that's why we have 600 over 10, which is 60. Now, derivation from the mean of each of the data will now be 65. Look at this. We have x minus x bar. The x bar actually means the mean. This is x bar, the mean. So for 65 now, the derivation from the mean will be 65, 65 minus, what is the mean? 60. So this is 5. So that means it is 5 that plus 5 rather. It is 5 that 65 have deviated from the mean. That's exactly what we have here. Now for the 64, 62, we have 62 minus what you have in the mean. For the 461, we have this. For the 60, 60 is actually not deviating from the mean, 0. For the for the second 62, this is second 62. This 62 is this. For this 61, we have this, and so on and so forth like that. So the derivation is actually how far or the degree or the extent at which any of the data have deviated from the mean. So whenever we add all the deviation from the mean together, it must always sum to give us 0. You can try it. Whenever you have any means of finding the deviation of the mean, when you sum all the deviations together, you have 0 as your final answer. Now, we can try and look at this together as a class activity. You can do it at your own leisure. Calculate the range. We are asked to calculate the range of these two data. And we also asked to calculate the mean deviation. What you have to do there is calculate the mean of this first one, and then try to now be deducting the mean from each of the data. Then what you have is the mean deviation. So that's about that. Let's look at the variance. That's the third thing I want to discuss here. Variance is the arithmetic mean of the squares of the deviations of the observations from the true mean. It is also called mean squared deviation. When you square the deviation that we just discussed, what you have is variance. So for the ungrouped data, our variance is summation x minus x bar, everything squared, over number of the data. You know what x stands for? X stands for the individual data, while the x bar stands for the mean. The x bar is the mean. So if you have a group data that has a frequency data, our variance becomes summation f, that is frequency, x minus x bar over summation of f. You know what this stands for? When we try an example now, you understand this better. And when you look at it, you must be, we discussed last class how to calculate the mean, mode, and median for group data. And the last two classes, we also talk about how we calculate the mean, mode, and median for group data. So when we have a group data, we have x, summation of x minus s bar squared. That is the mean deviation squared over number of the data. But when it is group, we have the summation of the frequency multiplied by the mean deviation squared divided by the summation of the frequency. Now let's look at a typical example about the application of this formula I just put forward to us. Calculate the variance of the following distributions of the ages of 50 pupils in a secondary school. Assuming that we take a sample of 50 pupils or students rather in a secondary school. And the question says we should calculate the variance of their age distribution. Those, the 10 out of the 50, 10, those are of ages 10 are 18 learners, 12 are 4, 13 are 6, and so on to up to 16, they are 4. That's the number of the age that we are considering. Now, the first thing here is to make your table. The table, the first one is making your X. This is your X. X, make your data like that, your X. The second one is your put your frequency. This is your X. Put your frequency. That's the number of pupils there. Then calculate your FX. That is your frequency by X. Don't forget this is an ungrouped data. This is an ungrouped data. Now, after that one, calculate your deviation. Your deviation is actually X minus X bar. Now, don't forget, we now have we are getting the modulus here. The modulus, that's the slant, the slash you are saying, means that you must take the positive value. So if what we have inside this is negative, if it's, for instance, if x minus x bar is minus 3, I will have to write plus 3 down. So you can see that all the values we have in this column is positive. That's the essence of the bar, this bar you are seeing at both ends, positive value. That is how to find the deviation. So you know x minus x bar. So by the time you find fx, we now look at finding the mean. Mean is summation of, look at this, summation of fx over summation of x. So excuse me. And summation of fx is 628. And summation of f is 50. That's why we get the mean. So this is the mean. So we now calculate the deviation of the mean from the mean of each of the data. So for instance, for 10, what's the deviation of the mean? That will be 10 minus the mean. 10 minus 12.5, that will be minus 2 point, we are using approximate value of this. 10 minus 12.6, that will be minus 2.6. That, but the modulus, it will now be 2.6. That's why we have 2.6 there. The second one is 12 minus, that is 12 minus 12.6. That will be minus 0.6. But the positive value will be 0.6. That's how we did all to this level. Now, the square of the first of this column, the square is this. Square of the x minus s bar, the modulo, the square. So that's why we have 2.6 squared. We have this 0.6 squared. We have this squared. Then after it, we now have frequency multiplied by x minus x bar. I think you understand that. The frequency, this is the frequency. 18 by this. 18 by this, we have this one. 4 by this, by this, we have this one. 6 by this, we have this one, rather. 12 by the 1.96, we have, that's how those ones are got. I want to believe you are clear about how the table are made up. Okay. Now, let's now look at the formula for the variance. You know, the question which find the variance. Variance is, this is a frequency data. Don't forget, this is a frequency data. So we are going to have our variance to be EF, summation of frequency by x minus s bar square. Don't forget, this is frequency by x minus, this is frequency by x minus s bar square. So what are we going to do? The summation is already here. So everything we are having up here is already here. That is 228.4 divided by summation of the frequency. The frequency here is here. So that is about that. So that's why we get our variance to be 4.6 in an approximate value. Okay. This is another one. Calculate the variance of the distribution below, 90, 80, 72 up to 34. The first thing is that their distribution, this is the x values, which is distribution. Now, because distribution is not a frequency distribution, it is not a frequency, so we are going to use the formula summation of deviation squared over number. Don't forget, deviation squared, deviation squared will actually be x minus x bar everything squared. That is what we call D. That is D. That is actually D. That is D. S minus S bar squared. Are we together? Okay. Now, if that is the case, this is a data that is not group. So we don't have to be calculating the frequency or multiplying by the frequency. Our mean is just addition of all the data divided by the number of data. So that's why we have our mean to be 60. So that is when you add all the data together and you divide it by the number 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10. So we have this one to be 600. That is all addition of all the data over 10. So when we get that one, the mean is 60. The mean is 60. Do you understand? All right. Just 1 minute, please. All right. Sorry for that. I want to put that off. Now, what is the variance? The variance actually means the summation of the deviation squared over number. And look at this. This is deviation. Each of the deviation is in this column. Because the first is 90. 90, that is 90 minus the mean. S minus S bar. That will be 30. The second one is 80. 80 minus 60. 60 is the mean. That will be 20. Third one is 72. 72 minus the mean. That is 12. That's how we got it here. Now, we are not going to look at the modulus here like the one that we did last. Because actually we are squaring it. So negative will cancel out. So deviation squared. That is x minus x bar squared. So deviation is x minus this is squared. So x minus x bar squared. That's what you have here. That is the column, this column squared. So the total give us 3,000. So that means our variance will then be summation of the deviation squared over n. That is the variance when the data are not grouped. So we have this one to be 3,000. That is the deviation. That is x minus s bar squared. That is which is deviation squared over the numbers of the data, which is 10. So our variance is 300. I want to believe you understand that. Now let's quickly look at the standard deviation. The standard deviation. The standard deviation is the square root of the variance. So because both of them go along each other, or they ask them interchangeably. They can also find the variance or find the standard deviation. The square root of the variance. So if you want to find the standard deviation, if you can say find the standard deviation, the square root of the variance is the standard deviation. So if the question gives you variance, the standard deviation will actually be the square root of the variance. So just put the square root on top of the two formula for variance, what you have is standard deviation. So for on group, that you have these two formulas, just like when I gave you for the variance. Look at the example. Find the variance and standard deviation of the set of the data. You have 2, 5, 6, 3, and 4. You have the data here. S minus S bar. The mean will be addition of everything divided by number. We have 5 of them. So 2 plus 5 plus 6 plus 3 plus 4 over 5 give us the mean. That's why we get the mean to be 4. Then S minus S bar, that is 2 minus 4 minus 2. That will be 5 minus 4, 1. 6 minus 4, we have 2. That's how we got it down. Now, the S minus S bar squared, the square of the column here. So that's what we have here. And summation of that is, I told the summation means addition, is 10. So the variance will actually be summation of x minus s bar squared, which is deviation, this is deviation, this is deviation. This is deviation squared. Summation of the deviation squared over n. That's variance. And that's what we have here. Summation of deviation squared, which is summation of x minus s bar, which is 10, over number, which is 5. So the variance is actually 2. What is standard deviation? Square root of variance. So standard deviation will actually be square root of 2, which is 1.414. Wow, we can also look at this together. I want you to perfect it yourself. We have the group data 10, 12, 13. We have another on group data 14, 15, 16. And we have the frequency there. I have given you the value of the standard deviation here. I want you to work from the table, calculate your frequency, fx, summation of x minus s bar squared, and get this out. That's your task. That's the second one after the first one I gave to you. Now, you can also look at this as your class activity. You have two questions here. The first one is for the table, and the second one is for the second table. You are asked to calculate the standard deviation and variance in each of the tables that you're having. So I want you to be writing this inside your, I told you last class that write all your class activities and your assignment inside your notebooks. We shall call for it anytime from now. So don't just be caught unaware. Write all our assignments, our class quizzes on a separate book. Anytime we can call for it. Now, this is an example that has to do with the practical application or in capital market. Look at this example. When you want to, let's say we want to apply this to the practical sense. Two groups of 8 students in a class were given a test in English. Two groups. Let's say we have a class, we group them into two. So we call one group A, we call the second group B. We now give the first one in that English test, they score group A, they score these values. That's the group A. While the second one group score this value. Actually, there are 1, 2, 3, 4, 5, 6, 7. There are 8 per group, according to what I'm saying. So the question says we should calculate the mean, range, variance, and standard deviation of each of the group. And the question also says which group had less variation in its marks. Now, for group A, let's do that for group A. Group A, we have 60, 70, and look at it. This is x minus x bar. Now you get the mean. Mean is x bar. Mean is just addition of all these together divided by the numbers, divided by 8. I think there are 1, 2, 3, 4, 5, 6, 7. There are 8. So when we add all these data together and you divide it by 8, what you get is the mean. So then that will help you to get the x bar. That is 60 minus the mean. We have this. 70 minus the mean, we have 7. 50 minus the mean, we have minus 13, like that. So the modulus now, which is the positive value? You can see the positive value, x minus s bar. That's why you just neglect the negative. So that's why we have the 3, 7, 13 to help this. Now, what the square of this is giving us is what you have in the last column. Now, we can actually get the mean now. That's the mean. And now I explain that mean is the addition of all this data over 8. So the mean is actually 63. So the range, this is actually 70 minus 50. That's the range, because look at this. In the group A, the maximum score is 70 and the minimum score is 48. So we have this range should not, let me look at that. No, the range here is wrong. It should be 7. So the range here this is 48. So we have 70 minus 48, not 50, because the range here is 40. So the minimum value here is 48. So what would that be? 70, 48. This is 2, 6. So the range is 22. So not 20. That should have been a mistake anyway. So the range here is 22, because it's from 70 minus 48. Let me just erase that and correct it. So 48. So this is 22. Now, the variance will then be summation of x minus s bar squared over number. And when you look at the summation of x minus s bar squared, or addition of all this, that summation gives us 896 over a number of the data. We have 8. So variance is 112. So what is the standard deviation? Standard deviation is the square root of the variance. And then the square root of the variance, which is 112, is 10.58 to 2 dp, 2 decimal places. In the group B, let's look at group B. Group B is this. What is the mean? The mean of the group B, you can work on, you can write this down and practice it yourself and confirm these answers. The mean is 64.25. The variance is 362.43. While the standard deviation, which is the the square root of the variance is 19.04 to 2 dp. Now the range here, let's look at the range. What is the range? The minimum is 44 and the maximum is 90. So the range of the group B is 90 minus 44. So 90 minus 44, excuse me, 44. What would that be? Let me do that. 90 minus 44, that would be 6. That would be 8, 46. So we have 46. That's the range. Don't forget the question asked us something here. They said, which group has the less deviation in its mark? Deviation in its mark. Deviation. So when you look at the deviation of this from the mean, addition of this, the group A, you look at the group B, deviation of the mean, which one have the least? That's what the question is talking about. The least deviation. Okay. I will want to put this forward to you also to practice. There are 2 questions here in which I have to find the range and the standard deviation of each of the data given to you in tabular form here. Also do that in your assignment book anytime you can call for it. Don't forget that you have to subscribe to this channel so that anytime any information is being dropped or any message is being dropped or any video is being dropped, you will be alerted immediately. That is very, very important. Thank you very much for your audience. See you in the next class. Thank you. Have a blissful day.